Welcome to today's science adventure. We're diving into the families of the periodic table, groups of elements that share similar properties because they have the same number of valence electrons. Those outermost electrons determine how an element reacts, bonds, and behaves. Let's explore. First up, the alkali metals, lithium, sodium, potassium, and their group mates. They all have one valence electron, making them super reactive, especially with water. Their oxidation number is +1 because they're eager to lose that single electron. Fun fact, sodium and potassium can actually explode in water. Next, the alkaline earth metals, beryllium, magnesium, calcium, and others. They carry two valence electrons, and they almost always lose them to form ions with a +2 charge. Calcium, of course, is famous for building strong bones and teeth. Now we reach the middle of the table, the transition metals. These include iron, copper, silver, and gold. They're strong, shiny, and excellent conductors of heat and electricity. Unlike other families, their oxidation states can vary, so we don't assign them just one number. That flexibility is why transition metals are used in everything from wiring to jewelry. Moving further right, we hit the poor metals like aluminum, tin, and lead. These elements tend to have mixed metallic properties. Their oxidation numbers vary, but for group 13 metals like aluminum, it's usually +3. These metals are softer and not as strong as the transition metals. Down at the bottom, separated from the main table, are the rare earth metals, the lanthanides and actinides. They're used in powerful magnets, lasers, and even nuclear energy. While their chemistry is complex, they share the metallic traits of reactivity and conductivity. Along the stair-step line, we find the metalloids, like boron, silicon, and arsenic. They're unique because they behave like metals in some cases and like nonmetals in others. Silicon, for example, is the backbone of computer chips. Their oxidation states vary, but their chemistry makes them essential in technology. The nonmetals include carbon, nitrogen, oxygen, sulfur, and more. They usually gain electrons when bonding. Their oxidation states follow their groups. Group 14, ±4, group 15, ±3, group 16, ±2. And of course, oxygen is essential for life. We breathe it in every moment. Next to the nonmetals are the halogens, fluorine, chlorine, bromine, iodine. These elements have 7 valence electrons, which means they only need one more to complete their outer shell. Their oxidation number is -1, and they are highly reactive. Chlorine is used in disinfectants, while iodine is crucial for our thyroid health. Finally, we arrive at the noble gases: helium, neon, argon, krypton, xenon, and radon. They all have full valence shells, 8 electrons, except helium, which has 2. That's why they are chemically stable with an oxidation number of 0. Helium fills balloons, neon lights up signs, and argon protects welding arcs. So let's recap. Families share the same number of valence electrons. This gives them similar chemical properties. Their oxidation numbers are predictable based on their group. The periodic table isn't just a chart, it's the blueprint of chemistry, showing us how elements behave, bond, and make up the world around us. From exploding alkali metals to glowing noble gases, the periodic table is full of personality. And now you know the whole family tree. Thanks for learning with me today. Don't forget to like, subscribe, and stay curious.